Okay, so what we we should have all the wells done, right? Like, because all he needs is the edits. So if they've been edited, then that's done. We got all of them edited, right?
Yeah.
Okay, so we just need to finish the interpretations, is what you're telling me, mineral solver and stuff, right?
Yeah. Yeah.
Okay.
For the Gantt project, I got a list of it, and I will show you. So the list band, these are the lists. Yeah. I think I will fix the well on the list first because they are stand out from the heat map, and I will try to finish them in 2 weeks maybe. And after that, I will group this well in Goose did well to feature selection by area. Yeah, and do another crowd QC again.
Okay, so for this thing,
Yep.
I'm trying to recall what Daniel requested, because I think originally he wanted us to look at he claims, he told me, you were sitting in the room with us in Midland. I don't recall what he told me, but he claims that he told me that he wanted us to start on, like the highest quality wells and work down the list to the lowest quality wells. So that's actually opposite of what you're suggesting, right? What I would do, so you've got your 63 or whatever that, are good because you know what was what happened with them. So what I would do with these wells in particular is, and maybe Tube can chime in here also, because he's working through a similar process right now in the machine learning database that we had, right? So this thing that we built those machine learning models from. So he's going through and fixing those up. That's essentially the exact same thing that we're going to do here. So Tube, how have you been doing that?
Which database? Oh, email database.
Yeah, so it's going to be the exact same process that he was doing there, but just here. So what I would do is I would high grade out the highest quality wells, the ones that are the least messed up. And then what you'll have to do, because we have no provenance on these things, we have no idea where they came from, who touched them, So what you'll need to do is go through them, through the workflow and check it. And I suspect that what you're going to see are things like, what we saw before with some of these wells, where somebody reran the clay module and they set like a flat 200 for gamma ray or something, right? And that's clipping the clay computation all the way down the well. So when you fix the gamma ray endpoints in the clay computer, then the clay comes out right, and then things look better, right? There's going to be issues with the clay endpoints themselves, the neutron density with the dolomite stuff and the wrong clay volumes. There's going to be issues where Daniel or somebody else that computes TOC does it in a different way, right? Like stuff like this.
Yeah, I already document. Yeah,
Daniel, he'll go through and use the TOC computer inside of IP. And that thing is sort of like a garbage dumpster where, if you ever look at it, I don't use it, but you can use it if you like to look at it, play with it.
Okay.
It's like every TOC equation ever known to man, and it just computes all of them. And then it's got like an average, a min, or a max or something, right? And to me, that's, the way that I look at things is different than most, I guess. I look at it from, first of all all of those models are entirely empirical and none of them are calibrated to anything. So you're just shooting in the dark. You don't know whether your answer is right, wrong, or otherwise. Number two, all of those models rely on some log curve as an input. Like some of them use bulk density, Schmoker. Quint Passey's technique uses resistivity. Other ones use sonic. Some of them use like uranium channel from a gamma ray or something, whatever. The whole point is, you can, if you've got calibration data, you can fit a model to a multiple linear regression that includes all those curves, and you're going to get a better answer probably. And that's exactly what we do already, because that's what I did. And I took all of our core data and I fitted MLR to it. So why in the fuck would I, anyways, point is you're gonna see TOC computations that are different. Then you're gonna see stuff like what you showed earlier, where Daniel, did whatever, a quick hit on one of these wells and somehow wound up with 90% clay. You're gonna end up with mineral solver models that are different than ours. Okay, so they're not going to have the clay endpoints. They're not going to have the TOC endpoints. They're going to have a different density for quartz, stuff like that. So we'll have to replace those, with our consistency to get it right. And then, then just burn through all these wells that are the highest quality. So I don't know how many we've got. I think it's like 165. So we should have like 100 wells essentially that we need to QC. And how many of that 100 are considered decent quality or better? I don't know what your flags mean there, but I'm guessing red is bad and green is good. So it looks like, it looks like maybe a third of them are bad and the rest of them are pretty good, right? So 60 wells, let's say. Yeah, what I would do is go through those 60 wells and, just clean them up. Go through them and see if there's anything wrong with them. And don't waste your time on the ones that are extreme washout and all fucked up and stuff. We'll come back to those later on if we even do, based off of Daniel's request. Like at this point, his opinion is we shouldn't even touch that data.
Yeah.
Okay,
Now,
got it.
So that's those two projects, like the Mustang draw thing. We'll have to come back to that maybe a couple of times. The first time we hit it with edits,
Okay.
and that's all we do, right? And the whole point of that is to get you've been sitting in on these meetings now, so you see what they're doing, right? They're building a post-stack inversion, and it's not much different than like the property modeling stuff that we're playing with, right? It's the same shit, building stratigraphic layers and picks with variograms and filling in stuff using the seismic data. But part of the inversion process requires them to make well ties, right? So they've got all these traces, and they got to have some data to tie that to bridge the gap on the model, because otherwise it means nothing without those well ties. So the next step, which we were doing before, but we kind of stopped doing, and I asked them about that in that meeting, and they said, well, we're trying to work on the low-hanging fruit, but we were doing pre-stack conversions. So pre-stack, when you've got a post-stack, I don't even know what this is. I think it's just a PSTM. So it's a time migrated volume, right? Kirchhoff migration or whatever. They didn't, So if you've got a depth migrated volume, it's a different story. But anyways, you still have stacking of the traces, right? Common midpoint gathers or whatever they're doing. They don't have information that could be used for elastic rock properties, which you get from looking at amplitude variance with offset and stuff like that, right? So gradients, Poisson's ratio. all of those elastic properties things come from the response of the phase and amplitude of the seismic data as a, as a function of the angle of your observation point. So, in order to do a pre-stack conversion, it's the exact same process as a post-stack, but now we need shear, because shear is
Yeah.
something that goes into the low frequency volume ties. So Mustang Draw, as with the rest of these projects, and there's going to be plenty more of them coming. This is going to be a steady stream of these things. I've been doing this for fucking 6 years now, right? Every one of them they just keep coming, because there's tons of seismic data all over the Permian Basin that needs to be reprocessed and inverted. So, step 1, do the edit. Step 2, do the mineral solver. Step 3, if we need to, or if we've got time, we come back and we do the rock physics work and get the shear right and the Poisson's ratio right, and all those things.
Yeah.
For use in pre-stack later on when they come and ask for that, if they do.
Okay.
So that's where that'll go. The grant thing and the Mustang Draw thing, at some point, like, I want to stop using these projects that we have on OneDrive, and I want to get back to the main Midland database, the one that I've been working out of this whole time, but you haven't had access to because it's too big to put on OneDrive, because it would fill up OneDrive immediately for everyone, because OneDrive makes like 50 copies of each file, and this thing is like 200 gigabytes.
Yeah.
So that's where the Z drive comes in. So you should be able to open the project now. And what we'll have to do is set up inside of the IP database, there's something called projects or whatever, where we can carve out a small section of it with a well list, so that you're not looking at the whole thing. Because if you got the whole thing open, it's going to go really slow. So if you're working on Mustang Draw and you only got 100 wells or whatever, we just put that well list in there. We create a new project called Mustang Draw that only involves those wells, and then you're done. But the whole point is we're all working in the same database, which means we don't have to worry about merging all these changes back in, which is a problem.
Yeah.
Now, we still have the problem of, what do we do about all the stuff that we've been doing the last year, right? That all needs to get merged. So, yeah, before we go there, we're going to have to test some things, and what we'll need to do, like when you get to a stopping point on Mustang Draw, which might be even this week, right, where we can just stop. And let's maybe we'll plan to do that Thursday or something.
Okay.
What we'll need to do is use the software that I've got to push that into the main database. And what we need to do is QC what happens. So the wells. The reason I want to do this is because you're working these things now. You've been in there. You know what you did to the wells. You know what the wells looked like when you first got them. You know what's changed. Okay. So we use my software, which is sort of scary or whatever, but we merge the Mustang database into the main one, and then you go through all the Mustang wells and look at them. Right? Just look at them and see, did I lose anything? Does all the data look correct? Is there any problems? No, all good. All right, fine. Then we'll do the grant one.
Okay.
Like next week or something, right?
Okay.
And because that's going to be a bigger, uglier fucking mess.
Yeah.
The other problem we've got is that there's diverging branches of this, which is going to require merges that aren't just overwrites. They're going to be adds, like a write on the side thing. Because, for example, we've got this machine learning database, okay? And we've done all this work in there to clean those wells up. Tube is in there fucking around now, cleaning things up and all that. That's all work. But some of those wells are Hobo Gypsy wells, which have rock physics work that was done that was never brought over to the ML database. So that data doesn't exist in the wells that Tube is working on, but we can't throw it away. We also need to keep that too, right? So
yeah,
this is going to be ugly for a little while. to go through all these wells. And then on top of that, some of the wells that are in the ML database are in the grant database. Some of the wells that are in the fucking Hobo Gypsy database are in the grant database. Like we've got lots of overlaps. That's the problem I wanted to avoid in the beginning, but things kind of got out of hand and now we're at where we're at. But we'll get it done. And once we get it done, then we work from that Midland database on the C drive from there on in, and we won't have that problem anymore. The other thing that I want to do is start using the studio software more to, run bugs out of it. Because every time I use it, I find more problems that I got to fix. And I spend all day long trying to fix problems that, stopping me from doing what I'm trying to do. I can't get something done. But there's a lot of interesting things that I've added to this and changed that, could, hold on one second. Who the hell is this? 315 area code. Who is that? If I don't even recognize that, I ain't answering. That is fucking New York, Syracuse, Utica. I don't know anybody from New York. I do, but I don't know what they leave a message if they need me. Probably fucking Adam Carey or something, one of my old coworkers. I don't know where what. Anyway, some of these things I added, can help you with some of the work that you're doing. So, I don't want you to waste a lot of time, but for example, here, I'll share my screen briefly. So this stuff too, like it should work now where you can push and pull and all that stuff, publish the wells, that should work. You should be able to put this, database on the Z drive and work off of it. But this is an ML database with those 72 wells. This is an older copy of it that I just used for testing. So you can do now. There's this thing called a model factory. So what this does, interestingly enough, this does what you did for the ML database. So this builds that whole mess, right? So what you would do is you would take your tops like we did before, right? And I don't know why that didn't immediately populate, but like you group these things together. There you go, Grayburg and San Andres, right? You would put whatever else in here. You can add these things, add the Glorietta separately, add the Clear Fork, Sprayberry, Joe Mill, Dean, you put together. Sorry, hit the wrong button. Group them together, right? So you did the same thing that you did before. You select all the wells, you put all your curves in here, and then you got this thing like a must or a may, which means that, do I have to have it to run or do I not? And so obviously, like gamma ray, we must have. Resistivity, we must have. Because if we don't have those two, we can't reconstruct anything. Everything else is a may. Maybe I got row B, maybe I got PE, whatever. We can even say that you got to have row B or something, whatever. You set this all up, and then you set the outputs up. So the outputs are whatever, in this case, it's data predicting data, but it could just as easily be, where you select mineral solver outputs like we did for the thing that we did before. Right, so you come in here and you just select everything, right, so that you get a full exact replication, BBW, all the way through, every curve, right? Then you select light GBM, and then if that's what you want to use in your training time, right? You validate this thing. It shouldn't validate because I don't have any bad hole flags and stuff. Yeah, see, it's going to complain about a lot of things. But when you build it, what it does is it does exactly what you guys had to do. It runs all the models and saves all the models in a folder. And then you can use this then to predict stuff, and you can export it into an app for IP. So like we built a specific thing to predict, basic mineral solver outputs in the Midland Basin. If we wanted to build something in the Delaware Basin or the Central Basin platform, we choose different wells. If we want to use something that predicts NMR data, ECS data, right? We got that. We can make one of them. But we don't have to run it 500 times and save 763 models this time. It takes one click. All you have to do is just sit here and wait for the thing to run for like an hour and a half or whatever. It'll tell you, what the CPU hours look like depending on how many curves and stuff you got in here. How it fits out. Make sense?
Yeah.
So that's a huge one. We got these property models, where I've set these things up. Let me open a different database because this one doesn't have. I do Yeso or something, right? So the property models, like now you've got a couple different ways you can view them. So you can view them in 3D like this, like seismic, right? Where you've got, like an inline and a cross line or whatever. I could pull that across. I could pull that thing across. It's kind of hard to see. I'll get rid of that. So yeah, there's your inline and your cross line. I could put my culture on there so I can kind of see where I am. Say, okay, well, that's Eddy County. That's Lee County. I got my north arrow there on the bottom, so I know which way I am. There's my inline and my cross line. And I can kind of look through this,
Oh.
So I can also put wells on here, if I don't know, pick one, cherry vanilla, whatever, right? So there's the well. I can
look like
I can put the tops for the well, the name for the well, all that shit. I can zoom in here, right? I can see and configure this stuff. There's the drinker, there's the Blindberry, there's the paddock on that particular inline crossline pair, right? Now that's all fine and dandy, but this one I like better. This is the actual 3D viewer, right? So now I've got, a full 3D surface that I can kind of rotate around and zoom in on. I can do the same thing where I can peel it back, and create little cubes or whatever if I want, around the well or something to kind of look at the properties. The other thing I can do with this is instead of just coloring it by the property value, I can color it by formation.
Oh.
So that's the actual stratigraphic layering here, and if you dump the culture on there, you can see where you're at. So this is the position that you're in. There's north going north. There's the Central Basin platform over here. This is the Delaware Basin, right? And this is up here on the Northwest Shelf. So if you look at the structure, it's actually interesting, right? You've got this back shoal where you haven't fallen in the basin yet. And you've got this back shoal and then whatever the fuck is happening back there to those carbonates, right? Tidal, supra-tidal, flat shit or whatever, and shoal environment, right? The other thing you can do with this is you can create a movie. I can create a little movie and dump that somewhere. And it'll tell you it's rendering the frames on the bottom. And then it's going to encode it into an MP4. And then I should be able to, let's see. Somewhere in here, I don't know where the hell it went. I guess it did. I don't know where the fuck I put it. I put it underneath the data folder. So that's why I didn't see it. Yeah, so there's a movie now, and you can, so it creates like a little 3D rotatable
Oh, cool.
So now, and the same thing, you could put wells on here if you want, fucking put all of them. There you go. Show the wells, right? There's all kinds of wells. And then put the well names. I mean, at that point, you can't read nothing, right? See, a lot of these wells just barely penetrate the paddock. That's where they start logging, and then they go down deep, right? Also change the opacity on here so you can see through it, and also show the grids if you want to look at the grids. The grids, but it's got to be 100% opacity for that to work. The other thing you could do is put logs on here, right? So if I want to put my neutron log or something, I'll need to change the opacity to see where that's there. There's a couple wells with them, there is a neutron log. It's really hard to disorienting here to kind of see where the fuck you're at because of all the wells that are active. Yeah, so like you kind of do one of these numbers where I peel it. Geez, okay. So if this was a neutron model, then you could kind of look at and see, and it would help if you disabled all the rest of those wells, you can't see anything there. But you also make the log width bigger if you wanted to. You can see it better, right? So kind of like having Petrel, but not really. But again, the whole point here is once you build one of these, you can extract data out of it also. So you got a property model, you can extract things out, you create synthetic wells that don't even exist, that some, and make logs there from the model. So the other thing I put in here is a foundation model, which is also a predictive thing. I kind of fixed that over the weekend. It's not that good for high resolution stuff. You're never going to beat the MLNet stuff, but it's okay. And then the other thing is this formation recognition. So, for a lot of these, this does a pretty decent job of predicting tops where you don't have them. So if you got a new database, like this Yeso database, I've got tops picked in some of the wells, but I don't have tops picked in the rest of them. I have to fix the data first, get all the names, mnemonics and all that sorted. But once I get that done, I can train it to predict where these tops are, and it does it pretty damn close. So you can play with this in a Permian, right? Where you've got picks made already, you tell it what Clear Fork looks like, and then I don't know what the hell just happened there. That was bizarre. Still hear me?
Yeah, I hear you.
Yeah.
I don't know. My Teams thing just went fucking disappeared and came back. But the way that this formation recognition thing works, you can look in the help file about it. It uses images of the formation. So it's using TensorFlow to actually map. I think it's in here maybe. What a shitty help file. It doesn't even have any fucking pictures. Anyways, what it does is it takes each individual log that you put in and makes it a row and an image and colors the pixel. And then it, trains, this is what the Clear Fork looks like. This is what the Sprayberry looks like. And I've run it on blind tests so far, it works pretty good. Anyways, we get newer projects with lots of wells that are missing tops or something. That's something that you can do. And then I also added like a mineral weight to volume percent thing in here, environmental corrections, wellbore trajectory stuff, image processing, and cutoffs, insonations, a couple other things, fix some statistics stuff where there's a proper statistical thing. And then also, don't forget that we can export to IP now. So, you can do import from IP, point it at a database, pull it in, do some stuff, export it back out, create a new IP database from the studio project. So again, we get something that comes in across the table from Diamondback that's not too big. I'd like to try to work, 10 wells in here. And that's something that we can also do with the public Permian Basin database that we have. Right? We should be adding a well per week to that thing. We can create a studio project out of it and work inside of here on our one well type of thing and see what see how easy it is, right? And log, keep a journal of all the problems that you encounter that you don't like or whatever, and we'll fix it. But at the moment, like I put a curve renamer in here now too. So like if you kind of drag and drop stuff, like I don't want to have to run the other one. I want to use that as my caliper, right? So I don't know what just happened there. That shouldn't have happened. I drag it in there. That shouldn't have done that either, because it should automatically set like that. I don't know why I didn't do that. And then I can even do this, right? I drag and drop on there, type it in or whatever. I can set these up, save them, so I don't have to redo them, and then run this. It'll copy curves, So we're trying to get things to be easier if possible and faster. That's the whole point.
What is your version, Ran? Is that 1.0.54?
Well, I never updated the version here. It's been like that forever. But if you update the thing, I pushed out this, and you'll know that you've got it because it's got this model factory in it. If there's no model factory, you're on an old version.
Let's see. Okay, I got model factory.
What else? We need to really test all the pushing and pulling and all that stuff too. And when you set up your database in here now, you can configure it to, put your working files in a different folder if you want. And the way that the thing works is everything that you do, no matter what it is, should be going into the working files. You should never, ever touch that main database. The only time that you touch the main database is when you push wells, when you come here and you publish. That's the only time. So, it's a lot safer this way, I think. And then also, like, if you have some problem on your computer where one of these wells gets fucked up or corrupted or it's broken, you can just pull the well from the main database into your project. Shouldn't be a problem.
Good.
Trying to think of what else. So Sibalak, she accepted the offer, but she's not going to start for a month, which doesn't help me very much. But I don't have it. I can't do anything about it, right?
We wait her so long.
I guess so. Doug is out this week, so we probably won't meet with them like we did last week. I want to keep that recurring, to have a weekly petrophysics meeting with that group to stay connected. So we'll reconvene on that when Doug is back. So we'll have Thursday to kind of work on the Z drive thing, I think.
Okay.
See how that works out.
Yeah.
See what else. I did copy, if you can, don't work out of the for the Permian Basin project, like the public data one, I copied that to the Z drive. So if you go to ZIP public data, there's a Permian Basin folder. That should be the project that you're working out of from now on. So you can open that in IP. I didn't keep notes from yesterday's meeting with Corey. There's lots of stuff going on. So Harper got hit by a car. She's alive and okay, but she's hurt. You know, she got beat up a little bit. She was riding her bicycle, I guess, and a car ran her over in Midland. So I talked to her yesterday.
Get those soon.
Yeah, well, so the Harper thing, like she's building a team. So what, you know, up to this point, she's been kind of all by herself. And I think there's been enough interest in the work that she's doing on the business development exploration side that they're going to build a team around her, meaning she's going to have like a geologist, a geophysicist, a reservoir engineer, and, you know, relies on us for petrophysics. But there's going to be more work coming down that pipeline. At the moment, we already know about some of it, right? We've got the Penn Shale stuff, which I believe was that Thunder project.
Yeah.
We've got the Yeso stuff that I'm looking at right now, which is that other play. And we may have more that comes from other basins and some other places. So that's on the radar. The stuff that you're working on too, very important, right? But still sort of like nobody will make a decision on it. You know, Mike Handke and Ryan Jarvis now, I think, and Corey have all three kind of laid ownership on that, but nobody sort of says anything. So I think Mike is busy or just doesn't care. So, you know, we'll just continue doing what we're doing and building the framework and evaluating the results like you had there with that report. And once they decide how they want to do the facies, then we can just change it and run it. But in the interim, I think it's just the process of getting things cleaned up as clean as we can get them, right? We've got IP database, we've got all the curves loaded and depth shifted, and everything is in there ready to go. And we kind of just wait. Similarly, same thing with the seismic attribute workflow. You know, that came up again during the geophysics meeting last week, and I brought it up to Corey. He's going to go check with Dave and Jake and DeVar, because, you know, those guys are sitting there saying, well, we don't want to bother you. We don't want to, you know, use the contractor time, because there's that message that was spread about, you know, if somebody talks to PetroRes, it costs extra money, which is not the case. You know, we're not billing by the conversation or whatever. We're billing by the day. So, you know, as of this point, kind of, we've really been giving them a killer deal, because, you know, you guys are not quite mature enough that I can't go to them and charge, you know, for you yet. But that hopefully will change soon, because I think the contract runs out in September. So this year I'm going to try to renegotiate more money for, you know, the team. But so that'll be coming down the pipeline. And that project is obviously really interesting. You know, regression work using the wells, you know, the data in the wells, like porosity, V quartz, whatever we compute, and then taking the seismic data and attributes that we can compute from the seismic data, correlating them to upscaled logs, and then using that seismic data to fill in the 3D volume. Because every single trace pair, we've got across the entire grid, right? We can fill in a full 3D. So, we did a pilot of this already, and it worked pretty well. Better than anything that they had ever seen before. So that's saying something. It worked well. So I'd like to revisit that. And we just need a pilot project. In Studio, I've already wired it all up so that you can basically build models and then write it out to seismic. So we just need the seismic volumes that have the attributes, the seg-y files, to feed it, because it learns the relationships from those. Like, we also have to do a bunch of data science work on the front end of it, because some of the attributes, the geophysicists aren't necessarily thinking about these things with the data science hat on or mindset. So they spit out, all these attributes that are not very useful to us. Some of them, they increase with depth and stuff like that. They don't change or vary with reservoir properties. Something like instantaneous frequency, changes with depth, and that doesn't correlate to anything. So if we put it in our model, all it does is just make a mess. So we need to do like that permutation feature importance, like, feature candidate selection type of work up front to make sure that whatever attributes that we do use are the right ones. And then also to do the data science work to figure out which ones correlate the strongest to the different, labels that we're trying to predict. So, for example, porosity is very heavily reliant on bulk density in our rock, the workflows that we do and all that stuff, right? On the type of reservoirs that we have, you will see that Mineral Solver, although it says neutron density porosity model and sonic porosity and blah, 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 90% of the weighting that goes into the phi-t computation comes from bulk density. So bulk density very highly correlates to porosity in these rocks. Guess what? Z impedance. So that's something the geophysicist calculates, bulk density times compressional velocity. That correlates extremely strongly with porosity. Also correlates anything that has impedance, right? So like V lime, it's going to correlate very strongly with, so forth and so on. Some of these other things like Hilbert transforms, frequency-based stuff, wavelet-based stuff, I'm not too concerned. I don't think we're going to see any of that stuff strongly correlate with saturations but the work that I don't know that you met him because he wasn't in Houston for the conference, but John Amovi, friend of mine I used to work with, he wrote a paper on basically doing saturations from VP and VS. And he was a PhD student for Castagna at University of Houston. And he's been running around with this paper, presenting it at every single conference, which, by the way, all of my abstracts this year have been declined from all the things. So he gets his abstracts in, mine don't go in. Yeah, rejected from 4 conferences so far, I think, or 5. Egypt's rejected me. ICE Jakarta rejected me. Hydrofrac conference rejected me. And I think one other rejected me. So anyway, that's just me bitching. But the physics of it are proven that in different types of reservoirs, you can calculate water saturation using VP and VS. And if that's the case, then we should be able to correlate saturations to VS in our seismic conversion with our attributes. And any shear-based attributes should correlate to saturations, and we should be able to use them to calculate a saturation volume. Would that not be cool, right? The other thing I mentioned 100 times, but I never got back to you on, and I need to log into my Diamondback computer right now, is the Vidance data. They still haven't set me up with a login to get in there. I need a username and a password to access that. Once I get in, I'll just download all of it. And then we'll have all that high resolution Vidance data to start playing with, to see what we can do with it. So mineralogy broken down at very high resolution. The only problem with all this Vidance data is that it comes from cuttings. So cuttings are not perfectly on depth, and depending on how the bags are put together, stuff like that, you can have some differences. See if Mark responded to me. I doubt it. Yeah. Oh, there he did. He did. You have been added to the Vidance reporting group. Open Power BI report open. I'll see if I can, there's a OneDrive folder. Maybe I can just download all this stuff. So that's another thing I think we can add a lot of value to by getting ahead of that, because so far nobody's really done anything with it analytically. You know, Kelvin's been looking at it saying, oh, look at, there's like feldspars in the Joe Mill or whatever, like cool. But that's the extent of it. So, you know, we need to go one step further and actually do analytics and model building and stuff like that. See if we can find something to leverage that data on. Then, what else we got? We have neutron stuff coming from Ben. More of that, I think. I need to meet with Corey and Ben to finish that off or discuss where they want to go with it. More database and data stuff that we were discussing. But as far as petrophysics projects go, I think Kelsey's had a request on pore pressure and some things up there. We're going to see where that goes, but that may be something that we can work on as well. And yeah, I think that's going to be about it for now. And for Pinion, if you can, send me a note or email with a list of all the wells that you interpreted, because we need to get an invoice to them and get paid. And I think we agreed on a per well price, and I don't recall exactly how many wells we had. I think the first batch was like what, 13 or something?
13.
Right.
Yeah.
Then they added 5.
Yeah.
But really, we added another one on there too, right? So that was like 6.
Right.
Right.
So total, I mean, let's just say 20
19.
or something.
Yeah.
Or yeah, let's just say 20 wells.
Another well on the platform.
Yeah, we'll send me a full list. I'm just gonna say,
Okay.
I'm just gonna round it up to like 20 wells, because we had all these damn presentations, and I had to build a whole bunch. I had to do a bunch of stuff for them last week with gamma ray logs, building 3D models and all that shit. So I'll just charge them a well for that. And then that'll put us at 20. So that's a round number. That's easy for them to justify on their payments in it. Okay. And I'll have to go back and look, you see what the hell what the pricing agreement was and all this stuff, because I don't even remember. I got that somewhere. I hope. Got a proposal, let's see, proposed workflow per well, blah, 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 blah. Okay. Yep. Got it. All right, so. Yeah, just continue working on the grant thing and the Mustang draw thing and the Four Faces thing. And, we'll. Anything changes, I'll let you know. Otherwise, we'll check in with you maybe tomorrow on Thursday and with some updates and stuff, and we'll try to merge or move some of these projects on that Z drive.
Okay,
Got it.
All right,
all right. Thank you.
yeah,
Thank you,
bye-bye.
Ryan.
Bye
Bye-bye.
bye.